Hey guys, we're going to dive into the second part of chapter 6, if you will. This is like a little mini chapter, a lot like what that little chapter that we did on matrices. This is going to be very similar. I think you're going to find it just as easy. But again, it's just one of those things that they included it in chapter 4, but chapter 4 was so big that we thought, well, we just need to split this out into its own little mini chapter. And I think you'll be a lot more successful to be able to do this. So, intro to complex numbers, I can identify the real and imaginary part of complex numbers and simplify negative square roots. First of all, let's say that even though it's called complex numbers, it's not because they're hard. It's just simply because that there's actually two parts to them. First, what I want to do real quick is let's just look at something real quick that will kind of bring back some memories from last chapter. So if we look at x squared plus 9 equals 0, for example, and we were to try to solve that, what we would find is again, the goal is always to try to get this by itself, right? So I'm going to subtract 9 from both sides, and that's going to leave me with x squared equals negative 9. And you notice when I get ready to take the square root of this, now all of a sudden I kind of see that there is an issue. Because I've got x equals plus or minus the square root of negative 9. Well, we know that it's impossible to have a negative square root because by the definition itself, a square root is what number times itself will equal 9. Well, there's no numbers multiplied by themselves that will equal 9. And you may be thinking to yourself, well, what about 3? Well, the issue is this. You've got 3 times 3 is 9, and negative 3 times negative 3 is 9. But in order to get negative 9, I'd have to do negative 3 times 3, and those are not the same numbers. And they have to be exactly the same numbers in order to be a square root. So we kind of hit a dilemma here where that if we were looking at this from the concept of the discriminant, we would say, well, there's no real roots to this. And actually, this kind of makes sense if you graph this out. I've got the graph of x squared, but it's vertically translated positive 9. So that means my graph would really kind of look like this, okay? Which kind of makes sense. What that's really saying is there's no roots. It's not going to cross the x-axis anywhere down here, right? So what we say is there's no real roots, okay? No real roots to this particular quadratic. But the issue is I guess mathematicians said, well, you know what? We need to have some way to describe this and some way to help with this situation, okay? So they come up with this rule. They come up with this idea that somehow we need to make an imaginary number system. Yes, you heard me correct. An imaginary number system to help us deal with negative radicals. Okay. So they come up with this. This this is a special I equals the square root of negative 1. And so they define the square root of negative 1 as I so that you can somehow describe, okay, well, this particular thing, it doesn't have a real root, but it's got an imaginary root, okay? So they use these imaginary numbers to help resolve square roots. And so there's something really interesting with this particular concept is that this letter I is cyclical. And so I want to talk about what that really means. So if I take I to the first power, that's the same thing as the square root of negative 1, okay? So that's here, for example. And I'm going to draw this in the form of a circle. Well, that was a rough looking circle, but you get the idea. Okay? Now, if I take I squared, that would be the same thing as the square root of negative 1 times the square root of negative 1. Well, think about what really happens when I square a square root, right? If I take the square root of x times the square root of x, then that is just that's the same thing as saying the square root of x squared. And when I square a square root, I just come right back to the x. So actually, I squared is actually equal to negative 1, just the number negative 1. Let's think about this again here. This really gets crazy because now I've got I to the third power. So I to the third power would be the same thing as I squared times I to the first. Well, we know that I squared is negative 1, and we know that I to the first is the square root of negative 1. So now what I really get for an answer here is negative square root of negative 1, or negative I. So notice every time I'm going around here, I'm getting a kind of a different answer. I to the first is this. I squared is really negative 1, and I to the third is really negative I. So let's look what happens here when we go to I to the fourth. So I to the fourth is really just I squared times I squared. Well, I squared is negative 1, and another I squared would be negative 1, and so negative 1 times negative 1 is a positive 1. And here's the really crazy thing that happens here. If I take, for example, we won't do a lot of these, but if I take I to the fifth, really that's the same thing as I to the fourth times I to the first. Well, I to the fourth is 1, and I to the first is just I. So I end up right back at the same place that I started. So I to the fifth is the same thing as I to the first. So this just keeps going around and around and around in a circle. This would be I to the sixth. This would be I to the seventh. This would be I to the eighth, and it just keeps going around and around and around and around. So no matter what number you're given that starts with I, you can actually figure out pretty quickly just from this little circle here what that number would be. So let's talk about complex numbers themselves. That again is just a little bit of information, just kind of a fascinating thing that happens with the letter I. But when you're looking at complex numbers, they actually come in this form, A plus BI. And so the reason, again, they're complex is this would be your real part, okay? And this would be your complex part that has the letter I with it. So when we're talking about complex numbers, really all we're talking about is something that has two parts. That's the reason it's complex. It's not really the fact that they are complex in and of themselves. And so, for example, if we had something like this, 20 minus 11i, okay? And this is the way we're always going to write them when we have answers that we're going to be solving, and we're going to be adding, subtracting, multiplying, doing all kinds of things with these complex numbers. When you get your answers, you're always going to put them in this format, this A plus BI. So in this case, maybe your mission is just, okay, what is the real part of this complex number? Well, that's pretty easy. The real part is going to be right here, okay? So the real part is the 20. And then if you were asked what was the complex part of the number, well, that's going to be this negative 11i right here, okay? So that's quite literally all we have to do for one of the parts of this. Now, the other part of this, again, the reason that imaginary numbers are so helpful is because they can help you resolve negative square roots. So let's take, for example, and we'll just call this example, let me go back to my black pen. We'll just call this example 1. And if I had the square root of negative 8, for example, well, there's some ways that we can rewrite this. And this is a lot like simplifying radicals that we've done once before. So I could take the square root of negative 1 times 8. Now think about it. Those are still the same things. I've not really changed my problem. All I did is kind of separated it into two parts. Okay, so let's take that one step further now. Let's now split that into two different radicals. So now I have the square root of negative 1 times the square root of 8. Oh, how did that help me? Well, now I have the square root of negative 1, I know now is I. I can just rewrite it as I. But now I still have the square root of 8. And so you have to ask yourself, a lot like we did before, are there any perfect squares that are hiding in here? Well, if you think about it, 2 times 2, or 2 squared, equals 4, and 4 will, in fact, go into this. So let's rewrite this. We'll leave the I just like it is, but I want to rewrite this one now as 4 times 2. And now you can see how that the I is still here, but now the square root of 4 would be 2. Remember, this 2, everything in here is being multiplied. So the 2 comes to the outside, and the other 2 has to stay in. And so the last thing we can do here, just to try to clean this up, is my answer would actually be 2i radical 2. So you can see how I can take something like this that we have previously said is impossible. There's nothing we can do with that. And now we've kind of made it into a simpler form here as a complex number. Okay. So the other thing you're going to be doing is you're going to be solving problems that are related to complex numbers and really just simplifying those problems. So let's do another example here real quick. We'll call this example 2. And so I have the square root of -4 times the square root of -9. So let's just think about this again real quick, and we'll kind of explain it on the first one, and the second one you'll kind of get the idea. So here again, I can rewrite it as -1 times 4. The negative square root of -1 times 4 like this. And then again, the square root of -1 is I, and the square root of 4 is 2. So this very simply, this right here simplifies quite nicely down to 2I, okay? Now let's think about what we have now. So that is multiplied times. Now I've got the square root of -9. I can do a similar thing here, -1 times 9. We know that this can be split out one more time. And we know that the square root of -1 is I, and the square root of 9 is in fact 3. So you notice we again have simplified this down without a radical now. So now I have 2I times 3I, and you will notice that that becomes 6I squared. And we may be tempted right here to say, well, I'm done, I'm finished, I don't have to do anything else. But remember, we said just a few minutes ago what I squared really is. And this is one that you really need to remember. If you remember, I squared is the same as -1, okay? So you can see how this just kind of keeps building on one another. So here we actually have 6 times -1 because I squared is the same thing as -1. So 6 times -1 actually equals -6. And so we take this thing that, again, in times past would have been impossible, and we say there's nothing I can do with that. And now all of a sudden we get it all the way down to -6 is our final answer. So you can see again how this letter I, this imaginary number, can really help you to be able to simplify square roots as well as be able to understand complex numbers. So hopefully this has been helpful. Obviously, if you need any help, reach out to us, and we'd be glad to try to help you with this assignment. It shouldn't be too difficult for you today, especially the front page. The second page you may have a few issues with, but if you just get with us, we'll do our best to try to help you out with it. Thanks.